Okay, here I am. Hi everyone, welcome to Mathematical Beauty. Today I am going to bring you with me in the journey of GRAPPA10, which is the 10-year celebration of the creation of the GRAPPA Institute, which is an institute of research, and GRAPPA stands for Gravitational and Astroparticle Physics. They have prepared an event of 3 days, and I have subscribed, and I will bring you along with me, and I will show you around. Bye.
We start with our own GRAPPA spokesperson, Samaya Izanka. Samaya, the floor is yours.
Thank you, Jaco. So good morning.
I recommend this, okay, please wait a couple of weeks, then an update of this will come, is about to come, is really to set up what is actually the scientific landscape.
And we start to see this with the discovery of IceCube announced last week. We expect about as much neutrino as we expect gamma.
This technique, we become more or less sensitive to point-like sources or extended sources, which doesn't mean that one is right and the other wrong, or one is better than the other. It's essentially you can adapt these.
Hi, so basically there has been the morning, and there has been some talks, and they introduced the 3 days event. Now we are having lunch, Dutch lunch, bread with sandwiches basically.
At least a few hundred million years after the Big Bang, which is called the so-called cosmic dawn. So we know that after a recombination, when the CMB was released for 100,
all these those spheroidals. And then in the black points, what you see is the predicted gamma ray flux from dark matter self annihilation seen
in a magnetic field. If there is a gradient in our language means a current, an electric current, then that current produces, excites.
The Monte Carlo is a way of approximating an interval, right? So you can think of it as the probability of the data x given the parameters theta way over here involves interval.
So, but if you go to high energy, of course, there's much more heteronegativity and it's get a bit hard to actually reconstruct and say what is happening here. But you can see this is a very excellent
1,000-second time window, and here you can see the 1,000-second time window. In light blue, 2,200.
What exactly is the GRAPPA Institute?
GRAPPA, so as you can see here from the logo, GRAPPA.
It sounds Italian, right?
Yeah, it's not my fault. I'm an Italian faculty at GRAPPA, but it's not my fault. The acronym is not my fault. It was already there when we arrived. It stands for Gravitation and Astroparticle Physics in Amsterdam.
So we're about 20,000 kilometers. We go away, and of course we first see, I think we see the moon. Yeah, does it see? Yes, that's the largest distance that we ever made. Okay, remember that because it's really tiny. It's really, really tiny. And if you fly further on, you meet the other planets. You see the solar system in the it's there with the sun in the middle and the planets around it. If everything is expanding in our universe, you see here, so all these galaxies are flying away from each other, then there must have been one point, and you put the doubling that on again, there must have been some point that they were all together. So let's simulate that over here. So we can never do this in real universe. So
okay, yeah, thank you very much. It's really a tremendous pleasure to be here tonight and take part in this event. So my job is to tell you about the Big Bang, and in particular about the origin.
Speak about black holes after hearing a song about black holes, so that's a first for me. So I'm going to be arguing tonight in a very short amount of time that black holes are one of the largest black holes that we know of. It's really big. It's about 7 billion times the mass of our sun, which means the event horizon is about the size of our solar system.
I've been thinking about this for the last couple of days, and I think I actually attribute it to one of my physics teachers at school.
Let's talk a little bit about astrophysics. And in particular, this galaxy here, it's the Andromeda galaxy, 2.5 million light years from us, a highway from Rome to Teramo. Goes through the Constanza Mountains.
So let's imagine we have a bunch of telescopes looking at the foreground galaxy, and
Don't you think this is really interesting? Is it ChatGPT or is it something completely different?
Yeah, so I really look forward to all the amazing high resolution data.
Eventually they collide and merge, which is the peak in the gravitational wave emission, because that's the most nonlinear distortion of the space-time curvature.
Of course, and we hope that these detectors will give us enough sensitivity to be able to detect pretty much all the black holes that are there in the universe, which is this gamma S here. Then I'm going to move over to the gravitational atom, which again I'm going to defer lots of details to Jimmy's talk.
10 years earlier, we were sitting there and having workshops on the future of the field and what we need to do, and that it always takes 20 years and we need to get started now and all this.
The first paper on primordial black holes actually goes back to 1971, Stephen Hawking, and he realized that you could have black holes of the Planck mass forming in the universe.
Some things on the boundary, you're shooting rays through it, and then from all the information that you gather, you have to reconstruct what goes on the inside. And because that's inverse reconstruction, so
is really how it is justified that this will work.
Well, it is a very big step, and the reason why they are doing that is because they need to compete.
And then we need new computational models of cosmic ray diffusion in inhomogeneous medium. So, thank you.
It is, by its nature, some sort of theory of the multiverse in the
I was one of the 6 initial GRAPPA members. We actually started not really 10 years ago.
I don't understand what the topic is. Reading lately that Amsterdam is planning to remove red light. Stuff comes out quite naturally. Is there spot differences or is pretty much homogeneous all the time?
What the hell? What the hell? What the hell? What the fuck? I was actually recording a vlog of these 3 days, I swear. Okay, so let's pick it up from here. Okay. We walked 3 kilometers because Amsterdam is under a storm. Public transport are not working, and so we walked from a station to here. I met Lianis.
So as I said, the internet is not yet near the ice cube result, but I think the department definitely are heading in the right direction. That EV halo could commonly exist around pulsar, and the formation of EV halo could be insensitive to the configuration of the pulsar magnet.
Have some reasonable shift in the number of cycles that you would expect to see of your gravitational wave observation.
So you can do, say, I know RD, I insist I know the expression of RD, but I'm wrong, or maybe I can allow this
Click on it, it zooms in and it shows you when there's a lot of meaning in the color coding in here. So this is a huge simulation.
This system in binaries, which means it will generally consider a big black hole. By big, I mean usually intermediate mass, surrounded by this super elegantly generated cloud.
Very quickly, why do you want to have it clean? What does the xenon detector look like again? This is how this works. You want a WIMP coming in, and there's a nuclear recoil, there's some scintillation.
Mechanism is not that important for this approach.
you can have a very suboptimal actually redshift estimator in order to do the binning in the first place.
Back at the presentation I've given at the GRAPPA10 meeting, we had put together a mission.
But firstly, I wanted to say the most important message to you all is thank you so much for coming. Thank you so much to our amazing speakers.
These are 2 trees which are completely eradicated when I told you there was a storm. So now you believe me. Look at this. Hi, so the conference is finished. The 3 days event, GRAPPA10, has come to an end. And I gotta say I'm very happy. I'm very grateful I participated because I really had fun. And I think it was very exciting to be among those people. Sure, the content and the subject of the talks was very interesting and surely very highly technical and of high quality. But I gotta say that the moments I was most impressed were when I had the chance to talk, exchange a couple of words with Bernard Carr and Thomas Hertog, because they have been collaborators of Stephen Hawking. And this not because Stephen Hawking is Jesus Christ, but only because he's the guy that, let's say, one of the most popular science book writer in the world, likely. I mean, popular books that anyone about science that anyone can read. And I got interested into this subject, so in physics and cosmology, thanks to him, because I read firstly brief answers to the big questions, and then a brief history of time, and then I went on with the other books of him. And I gotta say, it's very weird to realize the fact that you talk to someone that has been working with an extremely brilliant and excellent scientist and person as Stephen Hawking. And I think it's very weird sensation. It's very, I don't know, it's very strange. When I thought about it, I thought it was very strange. But I like it. I think it's very exciting, and I hope I will participate in any kind of activities like this one in the future. And who knows, I may bring you again along with me. I hope you have had fun, you found it interesting, and yeah, this was the Mathematical Beauty, and you can see that it can bring you anywhere. I will see you soon. Bye.